Good morning, everyone. My name is Thesis, and I'm pleased to present my PhD subtitle, Advanced Approaches to KPIManagement, Semantic Modeling in AI-Driven Forecasting. And this is done under the supervision of Professor Claudia Martini. Key performance indicators or KPI are essential tools for monitoring, evaluating, and reviewing the performance of various domains, such as business, sustainability, healthcare, manufacturing, legal, and technology. Very different KPI play a critical role in organization to improve the effectiveness in several key areas like education, across function, and aligning the daily activities to strategic goal, and as well as for helping to inform data-driven decision and improvise the resource and operation. And these are the some of my motivation for this work was to provide a modern, because nowadays modern organization deal with a fast-growing data environment and fast-changing data environment. So the digital KPI system are no longer enough. So my main goal was to the digital KPI system are fragmented, static, and reactive, and as well there was some second was existing forecasting model are limited and cannot handle dynamic data set. And the third was to there's increasing demand to integrate sustainability metric into performing tracking. And nowadays a new intelligent and flexible integrated framework is needed to meet the evolving business and sustainability goals. And your current data system faced several key problems. The first was fragmented and scattered KPI data across isolated system, limited integration and consistency. And second was the absence of semantic standardization, limit poor interoperability between the system and different domains. And the traditional model such as like integration, statistical analysis are weak for complex and dynamic KPI data. And the fourth was to many frameworks are static and they cannot adopt evolving business goal or sustainable requirement. And this difficulty for technical to integrate the environmental indicator into organizational performance tracking, and lack of unified framework like combining semantic modeling and AI forecasting. Other KPI systems are widely used and there are important gaps. First was lack of semantic standardization, no unified structure for defining and linking KPI across domains. And second was interoperability is weak, system are fragmented and domain specific. And third was limited use of data forecasting. Traditional model failed to capture complex and non-linear KPI data and absence of satellite indicators. And also there was the last was finally there is no framework that integrates semantic modeling with AI-based forecasting to do this separate. To address this result gap, I defined 5 main objectives here. To develop a semantic framework for consistent KPI representation using ontological RDF. And the second was to automate the extraction and validation of KPI across different concepts and integrate AI model, such as like machine learning, deep learning platform to forecast KPI, trend and performance, and support cross-domain application. And finally, I tested this framework with using real data, common evolution metrics to ensure it perform well. Let me summarize my core contribution here. The first was to develop a semantic model to represent and interlink data across multiple domains, and to integrate AI-based forecasting model, prediction of KPI. And third was to create a hybrid framework that combines semantic reasoning with predictive analytics, and we validated mentioned, we validated our framework. Two ways. First was the creation formulation, and second was the Spark theory. As you can see in table 1, table 3, creation formulation. Here we try to apply creation formulation, and as you can see, the most of the KPI value is near to 1, so it means this formulation to enter the next feature was correct, and p value is less than 0.05, so it's fulfill our requirement to extract KPIs. And then we try to validate using Semantic queries. And here we, as we said, we extract 3 KPIs in table 4. So as you can see, the original sample was 760, and KPI sample when we run Semantic query was 760. And also for table 5 and 6, it's quite accurate that the immediate of the extracted KPI was accurate and right. And again, then here we after validation KPI we through 3 kilo step here. We start from business process management, and we begin by establishing the business process. This include like management, methodology, and technology, and then we try to extract KPIs from these system, and then we have several KPI, and then we present our KPI using ontology, and then we prioritize the KPI and give a sequence, in what sequence organization can use our system to apply these KPIs. And then this slide presents a graphical representation of ontology. It showed how we organize different KPI using ontology, and it gives a structured view like a tree, and that helps us to group link different KPIs. And as you can see, there are directly KPI, directly or indirectly values on each other. And in figure 7, Venn diagram show how the KPI group. As you can see, some KPI are dependent on other are independent, and some are stored alone, independent KPI. And then in figure 8, we try to execute the execution order we did. Like the most of the dependent KPI start first, and then partially dependent, and then independent KPIs. Now we in part 2 we predictive model of using AI model, AI techniques. Here, as you can see, this is a common execution methodology for KPI forecasting based on machine learning. Here we also say apply data processing techniques, and then we apply data processing techniques, and then we apply machine learning classifier, and then we forecast area and evaluation. Then we forecast area and evaluation and superior KPIs here. And this is our methodology experiment order. That we, as you mentioned, we collect the raw data, then we extract KPI structure processing techniques, and then we apply tree-based algorithm, machine learning algorithm here, and then we train the algorithm and we reduce the KPIs here. And here, as I mentioned, we use 3 data sets, and we use 7 machine learning classifier here, and we use 3 or 4 evaluation metrics. And as you can see, the MSQRM outperform as compared to other algorithm in all 3 data sets. And the Shield 3 was the performance was low as compared to other classifiers. And then we try to show result in the diagram. As you can see here, the MSQRM outperform in all 3 you can say like metrics, MSC, MAE, and this is our RMSC and R square. And then this is our methodological flow chart for greenhouse gas emission using KPI measure. As you can see here, we also try to collect the data set from Environmental Protection Agency, and then we apply pre-processing technique like in data, reduce duplicate value and so on. Then we integrate all these tables in one column, and then we try to select the features using recursive feature integration, and then we extract KPI. Next step, we try to apply the deep learning algorithm, machine learning algorithm, and then we try to apply evaluation metrics. And here, as you can see, this is the list of selected feature from our data set. And then, as you can see, we selected only these 5 KPIs from the list of selected features. The feature have a higher mean and lower standard deviation value. And then we represent our list of KPI mathematically, and these are the list of KPI that we extracted from this data set. And as you can see, these are the results that we apply 6 algorithm, and as you can see, the accuracy which we call an F1 score, we use here 4 metrics here, and as you can see, the gradient boosting outperform in all 4 metrics, and as you can see, the canon perform less as compared to other or classifier. And this is a confusion metric, provide detailed evaluation of each classifier and perform performance. Model like random forest and gradient boosting show the best classification on base error as compared to our other classifier. And this is our bar diagram that, as you can see, the gradient boosting outperform and cannot boost perform weak as compared to other these list of machine learning classifier. And in this methodology, this is the execution order, and there are also we use three data set here, and we try to apply similar technique like machine learning. We first preprocessing, then apply deep learning, and then we apply regression metrics. Here we try to compare 5 deep learning with our architecture of transformer model to see which algorithm will work very well. So as you can see, the transformer model work very well because they have several layers to get or their output as compared to other deep learning model. So these are the results, and we use 4 metrics here too, and we use 5 algorithms here with transformer model too. And here, as you can see the result, all 4 metrics for transformer model outperform as compared to other all 4 algorithms. And then we represent our result in this diagram, and you can also compare this result with MA comparison approach data set, MSC comparison approach data set, and R-square comparison approach data set, and RMSC comparison approach data set. And conclusion. To address these challenges, the key game was KPIManagement was to integrate framework and combine semantic modeling and AI forecasting, and develop a semantic technique for KPI extraction, validation, and prioritization using ontology and RDF, and implement machine learning deep learning transformer model to predict KPI trends, and to enhance KPI system by enabling cross-domain application and supporting sustainability data like carbon emissions, and to validate the framework using neural net data from business data and environmental system. And there are some feature work that we can extend if we can extend in the future. We can extend semantic framework to additional domains such as healthcare, finance, and supply chain management, and integrate real-time data source for dynamic KPI forecasting and continuous update. Advanced of the ontology of relation method to automatically update KPI structure over time. And we further can enhance sustainability via ESG method to integrate advanced sustainability reporting, etc. And develop a user-friendly intelligent KPI dashboard or prototype based on a proposed framework. These are the publications that we publish during PhD. 6 papers are published and 1 is under review. Thanks for your attention.
And now, I think there will be some questions. Boris, Manuela, begins. It's my turn again.
Thank you very much for your presentation. I'm quite confused of all those models, but we are also dealing with indicators, like integrating with empirical approach. enterprises or either students to educate. Considering your presentation and taking into account the global standard for sustainability impact and the GRI indicators, which have more or less 250 indicators, we might like to have a sustainability report in future enterprises here in Arizona, how this can be applied and what we will see the main barriers of your algorithm which are not applied.
Actually, regarding sustainability factor, I think this data set from Environmental Protection Agency online is available online on in USA. And I think here to measure sustainability like for the carbon emission, we need to consider several factors for it. Like we have several feature like about, for example, you can say about the factories data, how much carbon dioxide they are producing. And if we have all this data, we can try to apply this list of algorithm, deep learning or transform model, to find out the prediction in the future with how much CO2 or maybe electricity they can emission in the next future.
So the algorithm is doing.
Yeah, we are trying to apply this. We have a data set that we collect online, as well, freely available, and then we try to.
Conferiamo il titolo di dottore di ricerca, filosofi doctor, al dottor Marco Esposito.
Presentazione eccellente.
Corona? Line Corona.
Conferiamo il titolo di dottore di ricerca, filosofi doctor, al dottor Marco Ciro Liscio. Conferiamo il titolo di dottore di ricerca, filosofi doctor, al dottor Nibras Abu Al-Sabr. Conferiamo il titolo di dottore di ricerca, filosofi doctor, al dottor Tariq Khan. Di nuovo ai neo dottori di ricerca e vi ringrazio per aver partecipato così attivamente a questo evento e auguro